In this lesson, we're going to learn how to factor trinomials. The first type of trinomial we're going to factor has a 1 for the leading coefficient, meaning that it starts with an x squared and no number in front. For example, if you look at the trinomial x squared plus x minus 30, the number in front of x squared is a 1. This case is much simpler than when there's another number in front. When factoring the trinomials, you're going to set up two parentheses. In the first set of, and then you'll fill in two spots. In the first spot, in both parentheses, you want to pick out something that multiplies to the first number in this polynomial. So something times something needs to equal x squared. And it's your job, and the x squared comes from being in this first spot. And it's your job to figure out what times what equals x squared. Well, we know x times x is x squared. So we'll fill in this first position with x and x. Now we need to figure out what to put in the second blank. The two numbers that we put here need to multiply to equal the last number, 30. And there's many number combinations that could equal 30. 1 times 30 is 30. 2 times 15. 3 times 10. And 5 times 6. So out of all of these number combinations, we have to pick out the one that works. The other issue we have is that 30 is negative. The only way to multiply to get a negative number is if one number is positive and one number is negative. So we'll also have to decide on the sign to put on our numbers. There's one last thing we need to consider when picking out the correct number combination. It needs to multiply to 30 and it needs to add to the number that's in front of x, which is 1. So let's see if there's a way we could combine numbers to equal 1. If we look at the last set, positive 6 and negative 5, when you add these, add to 1. And when you multiply negative 5 times positive 6, they multiply to negative 30. So this number combination, a negative 5 and a positive 6, works. This is now factored. Just to show you why some of the other combinations would not have worked, let's look at 3 and 10. If you put a negative on the 3 and a positive on the 10, that would add to 7, which is not 1, so we know it wouldn't work. Or if you put a positive on the 3 and a negative on the 10, it would have combined to negative 7, which again would not work because we need a 1, not a 7. You can see that same process would work. With this one, you would either get 17, if you, not 17. If you put the negative on the 2, you'd either get 13, or if you put it on the 15, you'd get a negative 13. And if you tried to combine these, you would either get 29, or if you put it on the 30, a negative 29. There's no way to add these and subtract them to produce a 1. So this is the only number combination that worked. Here's a second example. Set up your two sets of parentheses. And then remember, we're going to be filling in 4 blanks here. The first blank needs to be values that would multiply to give you the first term that's in the trinomial. So when we work this out, we're looking for something times something that can equal a squared. And we know that a times a is a squared. Now we're ready to fill in the second blank. The second blank comes from looking at the 55 for a multiplication and the 6 for an addition or a subtraction. Let's list out the combinations of numbers that could multiply to give 55. There's 1 times 55, and 2 won't work, 3 won't work, 4 won't work, but 5 will work if you multiply it by 11. Out of these number combinations, we know that one number needs to be positive and the other number needs to be negative because 55 is a negative number. So we'll either do -1 times positive 55 or +1 times negative 55. We also know that the number combination that we pick needs to either add or subtract to equal 6. So let's see what we could work out. If we do +11 with -5 and add those two numbers, those add to 6. And if we multiply +11 times -5, they multiply to -55. So this number combination works. Here's another example. Set up both your parentheses. This time I'm not going to show as many in between steps. Let's see what you could do in your head. So something times something needs to equal y squared, and that would be y times y. Now we need two numbers that multiply to give a +14. This time I'm going to go to the side and list it out. This is how we do factoring as we move it to a more advanced level. So numbers that multiply to 14, 1 and 14, 2 and 7. Now that we've listed the number combinations to multiply to 14, pick out the pair that could add to produce a -9. Keep in mind that to get a positive number, you could do a positive times a positive, or you can do a negative times a negative. Because the 9 is negative, we know that both of these numbers will have to be negative. If you add -2 plus -7, you'll get -9. That means that -2 and -7 are the factors that we needed. Another example, draw your two sets of parentheses. The x squared needs to break up as an x and an x in front. In the last term there's a y squared. Let's go ahead and break that up as a y in the back part. Now all we need to do is take care of our numbers. We have the number 55, which we know we need to multiply to, and we have the number -16, which we know we need to add or subtract to get to that number. List out all the ways to multiply to 55. Remember that 55 is positive, and you can get a positive by doing positive times positive or a negative times a negative. Because the number 16 is negative, we know that these are going to be two negative numbers. Now pick out the combination of numbers that could add to -16. Those are the numbers we put in here. So the final answer should be x minus 5y times x minus 11y. This problem looks a little different from the ones we've been looking at so far because the number in front isn't 1, it's 2. The method we've been using only works if the number in front is 1. But that's okay. 2 is the greatest common factor, so we can pull 2 out front. 2 divided by 2 is 1. 8 divided by 2 is 4. And 42 divided by 2 is 21. Now just try and factor this inner part. Carry your 2 down. We need to break the x squared up into x and x because x times x is x squared. Now we need to list all numbers that multiply to give -21 and add or subtract to give +4. So 21 can come from 1 times 21 and 3 times 7. We know to get a negative, we'll have to have a positive times a negative, or a negative times a positive. Let's see which numbers could add to positive 4. So we now have x minus 3 and x plus 7. If you put these numbers in a different order, that would still be correct. This problem looks like it's really got some issues. The number in front is 9, not 1, and the power is a 3, not 2. If you look at the example that we started with, you need a 1 for the leading coefficient and a square for the power. Let's see if we can make this happen. Looking for greatest common factor, we can pull out a 9 and we can pull out an x. Let's see what this leaves over. 9 divided by 9 is 1, and if you subtract the exponents, 3 minus 1 is 2. So the pattern we're following is divide the coefficients and subtract the powers, and repeat this as you move along. 63 divided by 9 is 7, and subtracting the power, 2 minus 1 is 1. 90 divided by 9 is 10, and the x has already been pulled out. Now we're ready to continue factoring. Bring down the 9x, draw your two sets of parentheses, and only worry about what's inside the braces. The x squared gets broken up, and now we need to list numbers that multiply to positive 10 and either add or subtract to make a negative 7. 1 times 10 is 10, and 2 times 5 is 10. And the way to make a positive number is either a positive times a positive, or a negative times a negative. Because the number we have is a negative 7, we know that both the signs will have to be negative. That way negative 2 minus 5 is negative 7, and negative 2 times negative 5 is positive 10. That's the final answer. In this example, can you pick out the greatest common factor? The number would be 2, and the same base with the smallest power is 4. Now we go through and divide the number and subtract the exponents. 2 divided by 2 is 1, and 6 minus 4 is 2. 14 divided by 2 is 7, and 5 minus 4 is 1. 120 divided by 2 is 60, and x to the fourth has been pulled out, so we don't need to worry about it. Break the x squared up so that you have x times x is x squared. Then list all numbers that multiply to give negative 60. But add or subtract to give negative 7. There's 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. To make a negative number, we need one negative and one positive. To produce the negative 7, let's put the negative on the 12 and the positive on the 5, and then these add to negative 7 and multiply to negative 60. This is now fully factored. Notice that each of the exponents inside the parentheses is 1. That means it's factored. This ends the lesson on how to factor trinomials when the leading coefficient is the number 1.